Balancing redox reactions using half reactions. This technique involves breaking an equation into two separate components, the oxidation reaction and the reduction reaction. Since neither oxidation nor reduction can occur without the other, we refer to the separate equations as half reactions. The overall equation is broken down into two half reactions. We remove spectator ions. Each half reaction is balanced separately, first for atoms and then for charge. Electrons are added to one side of the equation or the other to balance charges. Equations are compared to make sure the electrons lost equals electrons gained. That's important. Two half reactions are added together and spectator ions are placed back in. So our first example is Mg goes solid plus chlorine gas goes to MgCl2. Okay, so we have to decide what is oxidized and what is reduced. Well, let's look quickly here. Remember the rules: if anything's by itself, it has an oxidation number of 0. This also has an oxidation number of 0. Here we would have positive 2. And here we would have negative 1. We know that because chlorine, what column it's in, it always has a negative 1. We have 2 times negative 1. So that gives me negative 2. So Mg must have a 2. So looking at this, it looks like we go Mg to go to positive 2, it had to lose 2 electrons. Because it lost electrons, it's oxidized. Okay. Our other reaction that's going in is chlorine. Chlorine went from 0 to, so we had 2 chlorines. 2 of them went from 0 to -1, so there was 2 electrons being gained. So notice this. I said there's 2 Cl -1 ions. There's 2 of them. I know they're each -1. This is reduced. So now to balance this, we go to add it all together. Spectator means something's on both sides. We don't need to write it. On the left-hand side, we have, the same number of electrons on both sides, 2 and 2. No balancing needed to be done in this case. There should have been a 2. I messed that up. Sorry. Here we have MgCl. They're both ions. They would come together to be MgCl2 when we put those ions together. Okay, so it was originally balanced both for electrons and also for atoms. Here we have 1 Mg, 1 Mg, 2 Cl, 2 Cl. So that one was actually completely balanced. It was more process than anything else why we did that. Okay, example happening here. So first of all, we have to determine what's being oxidized, what's being reduced. Anything by itself has an oxidation number of 0. I know, what else do I know? Oxygen always has -2. That's probably what I'd do next. -2. Okay. What's going on here? I know that Ag must have a charge of 1. I know that because otherwise if it had any other charge, it'd have a charge of 7. There'd be a little 7 down below there. I know that the ion must be +1. Sorry. Okay. Now I know all of NO3, this polyatomic ion, it has to add up to be -1. Because if Ag is +1, NO3 must be -1. So O, I have 3 times -2 is -6. So I know that the N must then be +5. Okay. Copper in this case, I know it is +2 from that right there. And again, knowing that this has to, NO3 has to be -1, so I know that this must be +5. Okay, so right away I can see things that have changed. Copper has gone from 0 to +2. And so it has lost electrons, it's oxidized. Okay, in this case, we're not going to include NO3. It is not, nothing in the NO3 is being oxidized or reduced. It's found the same way on both sides of the equation. We're not going to include it. Okay, so here we have copper, I said, and it's going to go to Cu2 plus how many electrons were involved? It went from 0 to +2, so it was 2 electrons, and that's oxidized because it lost those electrons. It's on this side. Now let's look what's happening for Ag. We go from Ag, an ion, plus an electron to get this Ag solid. This is reduced. Okay, this is not okay. On this side, we have lost 2 electrons, and on this side, we're gaining 1 electron. Not okay. There needs to be the same number of electrons. So we're going to multiply everything on this side by 2, and now we have a loss and a gain of 2 electrons, which makes us all feel a whole lot better. Okay. Adding this back together. So I have the same number of electrons on both sides. I don't need to write that. I have Cu solid plus 2 Ag ions goes to Cu2 plus ions. Sorry, these should both be aqueous. I saw that from before. Plus my 2 Ag solid. Okay, now those spectator ions, those NO3s that I didn't include before, I need to put them back in. Okay, so Cu solid plus, I have 2 AgNO3 goes to copper NO3. That 2 positive means that there's going to be a number right there, plus 2 Ag. From our original equation, I saw what was aqueous and what was solid, so I'm just going to quickly copy those down. And when I say my original equation, I mean what was given to me here. Notice that this equation is now balanced for charge and for atoms. I have 1 Cu, 1 Cu, 2 Ag, 2 Ag, 1 NO3. Here I have 2 NO3. Oh no, I have 2 NO3s, 2 NO3s. So balanced for both charges and atoms. Okay, we're going to get a little more difficult. So here we have a reaction. We have to decide what's oxidized and what is reduced. So we're going to have to do our oxidation numbers, where any ion has an oxidation number of its charge. So let's do those ones. Those are really easy. Okay. Next, I would probably say my rule that oxygen is always -2. Well, if this is -2, these must be +1, so that the whole compound is 0. Here I have -2 for oxygen. Everything here has to add up to be -1. So I have -8, which means this must be +7. Okay. So what's being oxidized and what's being reduced? Well, it looks like iron right here goes from +2 to +3. So it has gotten more positive, so it has lost those negative electrons. So that is Fe 2 plus goes to Fe3 plus an electron. This is what's being oxidized. So now I have to look for what's being reduced. What's gaining electrons? Well, I see this guy right here went from +7 to +2. Now, if you're doing a question, you have 3 things that change charge, you've made a mistake, okay? You should have 1 thing losing electrons and 1 thing gaining electrons. Here, it looks like there's 5 electrons involved. 5 electrons plus MnO. I have to include everything related. I can't just include the Mn. Mn here is paired with O4. Here it's paired with nothing. So I need the O's, which also means I need the H's. So I'm going to have to use a whole bunch of things in my balancing here. Okay, so I said I needed the H's goes to Mn2 plus H2O. Okay, so not okay. In my oxidized, I only have 1 electron, and in my reduction, I have 5. So I'm going to have to do some balancing. I'm going to try multiplying everything here by 5. Okay, now my electrons are happy. Okay, are my atoms happy though? No, they are not happy. Here I have 4 oxygens, and here I have 1. So I'm going to have to multiply by 4. That makes me now have 8 hydrogens. So I need 8 here. It has not changed my number of electrons because the only thing gaining electrons was that Mn, right? We just needed that other stuff for balancing. So I balanced both for charge and for atoms. Okay, let's add this all up. I have 5 electrons on both sides. Now I'm just looking at everything on the left-hand side of the equations. I'm adding those left-hand sides up. I have 5 Fe2 plus MnO4 negative plus 8H plus. Okay, now I'm looking at all of my products. I have 5 Fe3 plus Mn2 plus 4 H2O. And if we go through, we'll notice that this is entirely balanced for atoms. And I know because of the process that I did, because of these 5 electrons on both sides, it's also balanced for charges. Okay, one more example to try. HNO3 plus Cu plus H goes to NO2, copper, H2O. Okay, things that are by themselves have an oxidation number of 0. That's probably what I'm going to do first. This would have a charge of +2. This would be +1 because they're ions. Next, I'm probably going to do my hydrogens and my oxygens. My oxygens are always -2, -2. This is +1. Okay, this whole thing, NO2, has to add up to be 0. I have 2 times -2, which is -4, so this must be +4. On this side, I know that H is +1. I know that everything has to add up to be 0 here. So I have -6 plus 1 is -5, so I need a +5 here. Okay, so that shows me now that copper got more positive. It's being oxidized. Cu goes to Cu2 plus there's 2 electrons involved. This is my oxidized. Okay, what is being reduced? The other thing that changes, it looks like, is N's. So involved with N's, we have O's and H's. So we need to include everything with O's and H's in our equation. Okay, so we have HNO3 plus H positive goes to NO2 plus H2O. So I'm just looking at the equation. I'm including everything with H's, N's, and O's. That's where I got that information from. Okay, how many electrons were involved? It looks like just 1 electron to go from +5 to +4. So we had 1 electron. Okay, oxidized we had 2. On the left-hand side, we just had 1. So we're going to have to multiply everything on this side. Oops, it doesn't want me to let me write by 2. Okay, so now this is balanced. I have 2 electrons on both sides. Excellent. Now I'm going to add this all up. So I have Cu. That's the only species on this first equation. Now we need everything on this side. Plus 2HNO3 plus 2H positive goes to, I have Cu 2 plus 2NO2 plus 2H2O. Okay, I didn't double check if we're balanced. On this side, I have 4 H's, 2 times 2. On this side, I have 2 and 2. I have 4 H's. Looks good. 1 copper on both sides. How many N's? 2 on the left, 2 on the right. 6 O's, 6 O's. This is completely balanced. Okay, so down below you have a practice assignment and you have its solution. So I'd like you to print both out, follow along, see if you need help. That would be a good place to look at the process and the answers. They're quite detailed. And then there'll be a hand-in after that.